Hello and welcome to the CDO Magazine interview series. I'm Derek Strauss with Gavroshe, and today I have the pleasure of talking with Vivek Anand. Vivek is Director of Data Science and Advanced Analytics at a Fortune 500 retailer. Vivek's had some really interesting experiences prior to that at various other organizations, and he'll probably mention a couple of those as we go. But thank you, Vivek, for joining me today.
Yeah, absolutely, Derek. It's a pleasure to be here. Nice meeting you.
So today we're going to be talking about a number of items, but the overall theme is going to be revolutionizing business with data science and AI. Data science and AI is all awe-inspiring stuff and so on. And I think we've all seen situations where people have jumped onto data science and AI because it's the bright, shiny object. And they get so taken up with that they lose focus on why are we doing this? Why are we doing this for the business? What's the real business value behind this? So that's really where we want to try and have our focus as we talk through this, is how do we use these bright, shiny objects to fundamentally revolutionize our business and bring business value. So we're going to do this in terms of a couple of segments, this interview. So for our viewers, please make sure that you pick up all three of the segments that we're going to have on this interview with Vivek. You're not going to want to miss any one of them. So this is segment one. And what we're going to talk about here is Vivek's journey into data science and AI. So Vivek, you began your journey into data science and AI in the highly regulated finance sector, financial services sector. I've spent a bunch of time there myself, so I feel your pain. What opportunities and barriers to applying data science and AI did you encounter?
Yeah, totally. I mean, you nailed it. Number one barrier really in data science, using data science in financial services is just the regulation part of it. So when I started in financial services, that was we were coming out of the 2008 financial crisis, 2010, 11, Dodd-Frank, all those regulatory infrastructure was being put in place. That kind of seriously limited what we could have done, right? But that said, we were still able to use a good deal of science to be able to solve financial services problem. Maybe as we go through this, I'll just give examples. The opportunities were typically, if you think about financial services, it's always hey, there is a financial model that either uses some sort of a discount cash flow or uses some sort of interest rate model, or some version of present value of cash, right? And the data science use cases were pretty rudimentary, right? And at that time, Bank of International Settlement, the Basel regulations that we have, they said okay, the 2008 financial crisis that happened largely because of people were not appropriately accounting for their counterparty risk, right? And what happened is the regulation said hey, you have to have cash on hand to account for changes in the creditworthiness of your counterparty. So this is too much financial jargon, but net, the layman's terms of it is, hey, how do you assess the creditworthiness of a creditor or your counterparty based on their attributes? And the regulatory requirements or the guidelines were hey, the most simple version you could do is use averages. But as all things averages, there's one outlier that throws things off, right? So, yeah. So we needed to come up with some sort of a robust model, right? And I assume pretty much everyone kind of is familiar with the credit rating. If you have top tier credit rating, you get best rates. Your risk is perceived least, right? Whereas if your credit rating is pretty low, as they call in the credit markets, triple C, double B minus kind of thing, your credit worthiness is worse than triple A, but better than triple C, right? So you'd assume that as your credit worthiness is a monotone function, it increases, decreases, the credit risk associated with it cannot overlap. They need to be monotone as well, right? Mm-hmm. And the fundamental problem that we saw with aggregations that were recommended as a starting point is they were intersecting. A couple outliers just makes AAA less creditworthy than triple B. That is not good, right? So that was the first use case of data science that I did in like maybe 10 years ago. So it felt like a very robust regression which solved for these challenges and was like less prone to outlier effects. And that was like that kind of opened the paved the way for us to kind of use data science. Our regressions were pretty robust. Our solution was adopted across the industry. So that was first way. The second thing, like another use case of data science that we could have worked in financial services was like, how do we price bonds? Again, there is a asset that traded, was liquid for a certain amount of time. It's not liquid any longer. Then you could use data science on comparable attributes to come up with a good pricing structure. But this was a challenge because this was not required as a regulation. And everything, financial services sector, because of the fiduciary nature and just the regulatory nature of it, is very black and white, as you know, right? You have to have a reason, and like you cannot deviate from the path you have set for yourself in the beginning, regardless of how your circumstances change. As they change, you cannot be agile. So that was a big barrier that I encountered in financial services. Like, hey, you could not AI at scale at a pace at which it is evolving, or data science at a pace it is evolving, to be able to solve the business problems that were either unsolvable previously or either were solved suboptimally, if you will, right? So that was a major challenge in financial services, but the opportunities were there. And like, actually, there's more and more adoption of data science in financial services now because of just some regulatory relaxations. And also, like, there are guardrails that have been put in place to make sure that the AI or data science just doesn't go haywire. But there is adoption. But like 10 years ago, when I was in, the guardrails were like not in place, so the regulatory challenges were there for sure.
Yeah. It was very rigid initially. There was very little, maneuverability. But you're right, it has changed quite a lot. But in the other sectors of the economy, it's been interesting to look at how the guardrails are different there, and the opportunities are kind of different as well. So as you transitioned out of the financial sector, what were the changes that you saw and encountered, and then that sort of led on to your interest starting to focus around the notion of explainability as well. So how did this transition happen, and what did you learn about the importance of explainability?
Yeah, absolutely. Like, I mean, in financial services, I when I last worked on Wall Street, I was like VP at Citibank. I was starting to deal with regulators and controllers and audit. And that is where I felt like, okay, I feel constrained based on the environment I'm working in, like what I can do. And that was kind of a pivot for me to move away from financial services and go into traditional retail and B2B. And the guardrails really vanished in some ways, right? So, I mean, yeah. I mean, whatever like I could do, the impact was seen or was visible in the company's top line, bottom line, right? So the guardrails were there in that sense. Like, I could not just come up with some crazy data science solution that is like not real world friendly, or it's not usable, it has bias in the model. And if those things are not good, they will start reflecting in your stock price, or like, external assessment, all right. But it really, other than that, other than just ensuring that I was building good data science, there were no constraints really. Like when I transitioned from financial services, I moved to B2B pricing, and B2B pricing was like starting to become a thing. It was like we were using traditional methods which were not super scientific, where a good deal of rules-based pricing was being done. And that is where the opportunity to use science became evident. Like, hey, here is a use case of science, and here is how I can do things better, right? I'll give you a couple examples, right? So in B2B, what happens is, it's in like you probably know, like it's an world where there are transactions happening bilaterally, right? There is negotiation, long sales cycle, and no two sales get the same price, right? So this is the landscape of B2B. And in that landscape, what happens is if you want to price like thousands of customers like one at a time, then you have a scalability problem, right? You cannot just keep on doing it one at a time, right? So there has to be some sort of a way to do it at scale while also doing it intelligently, right? And that is where the concept of segmentation comes into play. Like, how do you, even you have a ton of like 100,000, almost a million transactions that are seemingly different, how can you find common themes within those subset of transactions? How could you group those transactions into things that are like similar selling situation, not identical, but similar with similar traits? So that's where we started like building, using machine learning techniques that were starting to become more and more available. Clustering, you could use clustering, you could use regression techniques to identify what are the things that are like best explaining the variability in the data, right? So I'll just like give a couple examples. We were able to use unsupervised clustering techniques to identify like, okay, how many distinct buying patterns are in this big set of transaction? And then the machine learning would tell like, hey, there are like, let's just say 7 or 5. If I am assessing it, it looks like, okay, I'm just looking at 3 sets of customers, right? But the machine is telling me, no, there are 5. Then we go and figure out individual clusters and see like, okay, what is the difference between the 2 clusters? And that kind of like helped us group similar selling situations are built robust, as we call it, segmentation models. So that was like a paradigm shift from where I came from. We were not constrained. We could build models as long as I have a model that explains or does a good job. We are good. The second question you asked about explainability, right? I mean, I can build all the science, but at the end of the day, my end user is very likely not a person who is trained in data science, right? In that case, how do I make sense of like, okay, I took XYZ as an input and I'm giving ABC as the output. How did I trace my step through that? And explainability is a very, very important topic, which is, I feel, like a barrier of sorts in adoption of AI at a large scale across all levels of enterprise. So we were able to build some business intelligence framework in our solutioning and explain like, okay, here's the input, here are the steps that it went through, and here's the output it has come. So that was very rudimentary. And as we built upon it and as the data science capabilities became available, we were able to come up with good explanatory stuff like think about Shapley analysis. For every prediction, it can tell you like, okay, for every prediction, let's just say you come up with a prediction of like $20 for this mouse, right? Or a keyboard, right? It can tell you like X percentage comes from the color of it, Y percentage of that $20 comes from the location. So explainability eventually has become more and more available and helps drive the adoption. So paradigm shift in regulatory environments to like what we could do. And also to summarize, explainability makes it easier for us to interact with our end user, and adoption is becoming more and more easier as we go.
Mm-hmm. Yeah. Very interesting. The explainability side leading to better adoption, I think, is so key, because I think all of us that are involved in the data and analytics and artificial intelligence world tend to sometimes get so, excited about the stuff that we're doing. We forget that, we got to be able to explain this. We've got to be able to help other people to understand at the same level as we do. But in their language and in kind of baby steps, so that literally people, it's just going to be, they're going to grasp it and it's going to resonate with them straight away. So, yeah, I think a great point that you're making there, and certainly one that everyone needs to kind of have top of mind.
Yeah, I mean, like I'll just give you an example, like a quick one. We were working with I built a solution for our a customer in like components world, like building components. And their salesperson used to come and say like, hey, I don't agree with your pricing recommendation or pricing guidance that your model is giving. I don't feel good. My gut or my 20 years of experience in this space tells me it should be this. And the business intelligence dashboard that I talked about previously, that is like the first time I built that dashboard for them. Like it tells us like, okay, here are the attributes that I use to group this similar selling situation. Here is a range of prices that have been executed in the past, which are very similar to your selling situation. So can you explain why you think your situation is different? I'm not saying that leave money on the table or don't do the sales, but like, and that kind of conversation people started having, and then eventually we made it self-serve, and people were able to even look at like, okay, what is driving my transactions price recommendation to historical ones, and that adoption increased. People asking for exceptions on, hey, can I get an exception for this pricing situation? All of those drastically reduced. Just by make an input to the output pipeline and making it visible.
Yeah, very good. And it takes time. The point you're making is very important. It's not something that you're just going to snap your fingers and get immediate adoption. There's always going to be people that are going to say, no, that's not the way we used to do stuff, and it's not what my gut's telling me, and so on. So you have to put in the effort to work with those people over a period of time, showing them why, taking them step by step through it. So yeah, great points. And I think a fantastic start to the rest of the discussion that we're going to have. So let's call it quits for this first one. We've got a great foundation to springboard off for the next two segments that we're going to have. So to our viewers and listeners, please make sure that you come back and pick up on the next two segments. And we're signing out for now.